All right, Algebra 2 people here. We are down to 6 days left of e-learning, and so I know that's an exciting thing for you guys. Just like when you count down to the end of the school year, everybody's excited to be done, and maybe even more so this year than in years in the past. One of the last new things, we'll do some review and whatnot leading up after this, but one of the last new things we're going to talk about, and you can see it here, is an infinite geometric series, right? So let's look at this, and I want to make sure that we know, oh, is this infinite or not infinite, right? So if I look at this pattern right here, right, first off, it is a series because there's plus signs between it, and it is infinite not because it has the 3 dots there, but because it does not tell me how many terms that it has, right? So think about it. The last thing I see is the 3 dots. That itself does not make it infinite, but because there's no clarification on what kind of terms it is, then we can safely assume that it is infinite. All right. Now, we talked about this right here, that if you have an infinite series, infinite geometric series, it could or it couldn't have a sum, right? So here's what we have to do first. We have to decide, does this sum converge or does it diverge, right? If you recall the difference between those, converge means that the absolute value of my common ratio is less than 1. What that means is on a number line, right? If my common ratio is between -1 and 1, that means it converges, which means it has a sum. Okay? Now, let me give you an explanation of diverges here, right? And then we'll see what we really have for this pattern, right? So a diverge, if you recall, that meant that the absolute value of my common ratio was actually greater than 1. So again, what that means is on the number line, if I was thinking about this here, that my common ratio would either be less than -1 or greater than 1, right? If it is that, then the series has no sum, right? So it has no sum. So it might be as simple as, hey, find the sum of this pattern right here, but the issue is you can't because of what the common ratio is. So you would just say, you know what, sorry, can't do it, okay? But let's take a look here at this one. If we're looking at it here, recall how we find the common ratio, right? Maybe this one is easy for you, but it's always the number that we multiply to go from the first to the second, from the second to the third. It's that same number. So how we're going to find this is always take my second divided by my first, right? That's easy. That's just going to be 1/2. Right here, take my third divided by my second. That's also going to be 1/2. 0.25 divided by 0.5 is 0.5, right? So that means I have to think about this. My common ratio is 0.5 or 1/2. Which one does it fit into? Is it converging as a sum? Is it converging going towards a number? Or is it diverging right here, which means it's going away, right? If things are diverging from one another, they're going away from each other. The answer is converge right here. All right? So the last new formula, okay, that we are looking for here is this formula right here. Notice there's not going to be any ends in this formula, right? The reason for no ends is because it's an infinite series. So the sum is just my first term all over the quantity of 1 minus r. So in this pattern here, we could look at it. we could say, looks like my first term is 1. My common ratio was 1/2, or you could write it as 0.5 there. That means that my final sum is just 2 right there. Okay, so you're going to look at some problems here, class, and you just have to say, hey, you know what? Converge, diverge, find a sum. All right?